Good evening, one and all. I am Dr. M.D. Sirajuddin. On behalf of Vaageswari College of Engineering, I welcome you all the participants to this day 3 of 6 days online faculty development program. I take immense pleasure to invite our eminent speaker of today's session, Mr. Raj Verma, Security Engineer, RV Technologies, Hyderabad. Mr. Raj Verma has 13 years of industry experience in designing, implementing security enterprise system. His expertise covers network and application security, identity and access management, vulnerability assessments, penetration testing, and cloud security platforms like Amazon Web Services, Azure, and GCP. He is a certified security engineer with advanced qualifications in cloud and cybersecurity standards. He has worked with reputed clients such as Excel Valley, Wipro, and so on. Raj Verma, skilled in incident responses, security automation, cryptography, endpoints protection, and DevOps practices. He also has hands-on experience with Docker, Kubernetes, GitLab, and so on. With strong problem-solving skills and communication skills, he focuses on building resilient and quantum-ready digital ecosystems to meet evolving cybersecurity challenges. I would like to involve today's eminent personality, Speaker Raj Verma, sir. Sir, over to you, sir.
Mohammed sir, thank you for your introduction. Okay.
You're welcome, sir.
Good evening. Yeah. Good evening, everyone. I hope everyone is well, right?
Yes, sir. Your PPT is visible. Your voice is clear. Please continue.
Okay. So, coming to our topics today, our topic is quantum computing threats and threats to cybersecurity. Okay. So, before going to start, so nowadays we are all living in a digital world, right? So, like we are using the UPI, Aadhaar, digital lockers, WhatsApp, Paytm, SBI net banking. So it means that we are all are depending on online systems. So even though from the kid to the older person as well, so we are using mobile phones like internet, right? So but if I tell you in a 10 to 15 years, a new kind of computer called quantum computer can break all these of protections. So how it is it scary, right? So for that, we have to learn quantum computing and cyber security. Is it clear? I hope you are. Everyone is getting my voice, right? So yes, sir, are you
Yes, sir.
getting my voice?
Yes, sir. You are
Yes.
clear, sir. You are clear, sir. Please
Yes.
continue.
Done. So for example, in the 2019, the Google quantum computers, like we have a name with that, More. So solved in a problem in 20 seconds. Okay, so that will be take a supercomputer around, it will take to solve 10,000 years. Imagine what happened when such a power is used against banking or other systems. So I think if the person is facing any banking issue or else any other issue, it will resolve in seconds. So when if nowadays we are going to other centers bankings regularly, right? So it will take around 1 to 2 days to solve it. But a supercomputer comes, like a quantum computer comes, it will be solved in 1 to 2 hours. If any problem, okay. So that's why this seminar is very important to understand the risk, how it is works, and what we can do with using these quantum computers. Okay, I think I am clear. So I hope you understand as well. But then, first of all, what is quantum computing? So what is quantum computing? It means, so quantum computing is the next level technology based on the quantum mechanisms. As you are all are aware of that, normal computers. So it are working with bits 0 or 1, right? So in the same way, quantum computers are used qubits. So qubits which means that they have 0 and 1s and the both as well. So like superpowers or superpositions. Okay. So think like an example. Okay. Think if it is like in a coin. right? So a normal computer or normal bits like in a coin kept flat, either it shows heads or tails, right? So but a qubit or a quantum computers, okay, it if it is an a, it look like an a spinning coin. It means that it's having both the heads and tails. Until you stop it, it will run the same. Clear? Right. So this is a special power makes the quantum computers extremely fast in solving the tough problems as well. Okay. So why it is so powerful? So why the quantum computer have this much power? Means that I conclude with the 2 points. So because of qubits can be interleaved, like it have lots of sharing information instantly. Like the here the like we are if you are sharing some information to somewhere like in the world, it will take around 1 to 2 minutes or uh, 1 to 2 more than 5 minutes as well. Like in the department depends on the size of the file, right? So, but here the sizes doesn't matter and the distance doesn't matter. It will share immediately in instance only. Clear? Then in the same way, the next power of the quantum is parallel calculations. So in general computer will take the calculations for some few seconds, right? So, but the quantum computer will take the calculations within the seconds. It will complete the within in the seconds only. So they can test millions of solutions at once. They can randomly test millions of the solutions at once. Okay. So in real example, so take an example as IBM. So IBM already already worked with the quantums, right? So they have own test lab as well. So IBM is lost latest quantum system have overall around 400 qubits, I think so. I don't know exactly. So by 2025 or to 2030, they expect to machineries within the 1,000 plus quantums. So once we across 1 plus million qubits, estimated in 10 to 15 years, so the RSA, we are using RSA and ECC encryptions nowadays. Those will be broken like anything. Those will be not at all work for the quantums. Clear? So like in a let's take a normal example. Like everyone using nowadays IRTC booking, right? So nowadays we are all are using more like what is that? Abibus, Make My Trip. Like we are using n number of applications, right? So whenever millions of people are completing the booking, okay. So now we are using classical computers only, right? So the classical computers are allocated tickets within the seconds. But a quantum system is involved in that booking, it will provide the solution within instantly. Okay. So showing how it is powerful. So that is a difference between the local computer, like classical computer and the quantum computer. Right? Next. I hope my screen is visible, right? Sorry. Done? The slide is changed or not? Yes.
Now it is
So,
changed, sir.
yes. Today's our agenda is so fundamentals of quantum computing, so cryptographic vulnerabilities, post-quantum solutions, and implementation roadmap. So we will cover all these things in our session. Okay. So as I said, the quantum computing power and all the things, right? And as I said, the IBM things as well. Okay. Right. Next. So with using these quantum computing, we are facing any issues or our further generations. Yes. So even though in our cyber security, so in our security is also being in risk only. For that, I will conclude and within short and sweet. Okay. So current encryptions we are using RSA and ECC and define elements. So RSA is generally used for Aadhaar and banking websites and digital signatures. Okay. The same way ECs are used in WhatsApps, buttons, UPIs, and the Paytm, as you know, Bitcoin as well. So we are using n number of encryptions like this only. So in the same way, we have a DeFi element. So DeFi element is used in VPNs like Cisco's government secure common websites. Okay, done. So these all are generally we are using nowadays. So today the security like RSA, as I said, RSA and ECC depends on mathematical problems that are very hard for the normal computers. Okay, the basic example of that is the RSA security is depends on breaking a very large number into the prime numbers. Okay, so even though ECC is use very complex algebra with elliptic curves, right? Okay, then the classical computer takes thousands of years to solve these things. A normal computer will take the thousand of years to solve these things. What I said before, it will take around thousand of years. But take an example in a real time. It like try to guess. Take an example. Uh, Try to crack the ATM pin, a 10 4-digit ATM pin. It will take ages for the normal computer. It will take around 10 to 15 years. So, but in the quantum computer, can crack it much faster using special algorithms. Okay, right. As I said, RSA encryption, okay, ECC and DeFi element key exchange. Done. So, take another example for that in the same way. So when you are logged into SBI networking, your data is encrypted using RSA. Your data is encrypted using RSA. Today's supercomputers needed trials of years to break it, but a quantum computer can do it in an hour. Do it in an hour. Okay, so this is the power of quantum computer. So that's why the quantum computer is very fast generation computer. Then right. So for that quantum computer, the world is introduced to algorithms. So that is one is Shor's algorithm and next one is Bruce algorithms. So I will discuss later these things. Then right. Next. So how impact is it from the quantum computer is? So that is nothing but harvest now, decrypt later. Okay. So I will show that one as well. Okay, even the last one. No worries. Then no worries. The slide is missing. Yeah. So I conclude within a short way. Even a hacker or a foreign agencies are already collecting encrypted data today. Okay, so they are already prepared to hack the data. So that's why they are collected data today only. So in 2035, when the quantum computers mature, they will unlock all those files. Clear? But in the real example, imagine Pakistan or China secretly recording our encrypted Indian defense communications today, only to decode them in a 10 years or after 10 years. That is a very serious national security risk we have to face. So that is a very big problem to our nation. That's a very much effective to our nation and the world as well. Okay. So next. So how quantum computers break encryptions? So how it will be shows. So as I said, we have two algorithm for that. So one is Shor's algorithm and the Groover's algorithm. So Shor's algorithm is a biggest test to RSA and ECC algorithm that we already have, right? So how it will be effective, we will see. So Shor's algorithm is it's in a big number of it can faster than big numbers of very fast. Okay, this means that RSA and ECC is the backbone of internet security, but it will be breakdown by the Shor's algorithm. As example, so a 2048 bits key from the RSA can be cracked in a hour if a big enough quantum computers comes. Clear? The next. Then in the same way, so it is related to an Indian example. When we talk about Indian example, so other authentications, as I said, other authentications and IRCTC logins and SBI's YONO transactions, all are used RSA and ECC algorithms only. If sure algorithms runs on a big enough quantum machines, so all the Aadhaar and UPI data could be exposed like anything. We don't have any data in our hands as well. So in the same way, if Grover's algorithms work as the same, so it is for the speed of brute force attacks. So Shor's algorithm for the uses of numbers things like then the same way Grove's algorithm is used for the speed. So it effectively cut the strength of the what we have the encryptions. Okay. The same way, if you take an example for the Grooves, so if a normal hacker take 1 crore years to guess a password, generally assume that if a normal hacker takes a 1 years to guess a password, with a Grooves algorithm, a quantum hacker may take 1,000 years. Still, it is big. Why it is but much faster? That's why. So I hope you clear, right? Are you following, guys? Right. So next, why Shor's algorithm is more faster? So it means that it is a factor largest integer in polynomial time. So it is as well that solve discrete algorithms problems like anything. Like it will solve the problems within seconds. Okay. So it breaks the RSS, as I said, and DSA, ECC. What we have the right current algorithms. Okay. And what takes billions of years for the classical computers, okay, that could take hours or days with sufficient advanced quantum computers. In the same way, coming to gross algorithms, so it provides quadratic speed up for unstructured searches. So as I said, it will take very speed for the search operations and reduce symmetric key security by half. The same way it will affect AES and SHA2 and SHA3, etc. The same way it is fortunately a doubling a key length. Like as I said, AES 256 instead of AES 128 provides equivalent protections. I will discuss later regarding these things. Okay. In the same way, so how it will be impact in India? So in the real world, how it will be impact? So in the real world, it will be impact on banking and finance, government and defense, healthcare, daily life usages. So already we discussed in the daily life as well, right? In the same way, how will be impact in each and everything we will discuss right now, right? If quantum computers become a practical thing, so it will be appear in the world. So it will be affect all these things. As I said, banking and finance, government and defense, healthcare and daily life. Okay. So in the banking and finance, how it will be impact? So India are using UPI transaction, I think overall 18 lakhs per month in I think in the as per the 2025 ratios. Okay, those are all are depends on encryption only. All are depends on encryption only. Like UPI transactions or else Paytm, Phone Pay, all are depends on encryption only. A single breach could wipe out all sorts of customers' accounts. A single breach comes under an quantum. It will breach out or wipe out crores of customers' accounts. It means online transactions like UPI, net banking, card payments, or Paytm can be hacked. Right? So these are real-time impacts once the quantum computer introduced into the world. The same way, in the same way, the government will be affected and the defense will be affected. In like what we have departments in the government. So the Indian Army, we are using uh, secrets. The same way DRDO, we have some secrets. The same way Ra we have the secrets. Right? These are the common vulnerable things. So the important things, right? That secret communication can be stolen once the quantum computer introduced the world, right? The same way, take an example. During the attack, I think the attack name is Balkot, right? Balkot strike. At the time of Balkot strike, at the time of Balkot strike, the secure communication were is critical thing. It is an important thing as well. So if the quantum computers are available to enemies, if the quantum computer is introduced in the world, so they could have read our entire strategies regarding the strike, how we will be proceed, all the things they will have in their own hands, right? So these much potential that quantum computers have in the real world. I hope you clear. The next, in the healthcare departments, nowadays we are all are using healthcare health cards, right? So most of the hospitals like Apollo, Ames are having insurance companies data. So we don't have that much, but in the US or UK, most of the people are, most of the insurance companies are store the patient's medical data. So in the India, it will just, I think in the 2022 it will be start. Okay, so from the 2022, the companies are stored the medical data of the user. But in the UK or US or like all the other countries who are already developed countries, so they already store the patient data. Okay, that patient records can be exposed. Okay, so if the quantum computers are introduced in the world, the data will be stolen like anything. So like which data is important? It means so nowadays everyone is saving their baby's DNA like stem in some stem stores we have in the Hyderabad as well. So like that data is leaked. Can you people imagine uh, how the how the problem is big, like how it will be appear in the world? So it will be take for the identification theft, or else even though it will fair take for the bio war as well, so bio targeting as well. So these many problems are we are ready to face once a quantum computer is introduced into the world. Clear? So coming to daily life, you already I already said we all are using WhatsApp, Gmails, Aadhars, eKYCs, Phone Pays, Google Pays, etc. So assume that even WhatsApp and Gmail are encrypted, can be broken with using these quantum computers. Okay. Same way, imagine someone is recording all your WhatsApp chats today. Just assume today, decrypting them after 10 years with a quantum computer. How scary it is. So just imagine, is it scary or right or not? Is it scary only, right? So this is called harvest now and decrypt later. So as I said, harvest now is decrypt later. Okay, done. Yes. So we all are facing many risks in real world. That is, one is financial services, the financial risk, defense and intelligence risk, health risk, and the banking level we are facing risk. So once a quantum computer is introduced, so we are ready to face these many risks. I hope you understand, guys. So then what is the solution for this? So is there any solution for this? Do people think we have any solution for this? I hope everyone is there in the call, right? Okay, no worries. Yeah,
Yes, sir.
yes. So we have solution for this. The solution is post-quantum cryptography. The solution is post-quantum cryptography. So with using this, we all overcome these above problems. Okay. So what how we will perform these post-quantum cryptography solutions? So I will let you know. Okay. Yes. To protect against quantum threats, so scientists are build quantum safe algorithms. So if we want to face any problem, before going to that, we are ready. In the same way, to protect against the quantum threats, the scientists are building quantum safe algorithms. Okay, so now the US or UK people are using this quantum post quantum cryptographies. They already build the things. So we will discuss after the classes. Like, again, second session we have, right? The session we will discuss these things. Okay, so these all are new types of cryptographies and encryption methods that even quantum computers cannot easily break. Okay, these all are new type of encryption methods. If even the quantum computer is try to break, it is not that much easy. Sorry for the trouble. Could you please hold on a minute? Okay. Yeah. Sorry everyone. Yes. So I hope my screen is visible, right?
Yes, sir. You are audible, sir.
Yes.
It's
Yes.
clear.
No worries. Yeah. Okay. Good. Done. Right. So with using new quantum cryptography technologies, so we are if you are trying to crack that encryption as well, it is not that much easy and it is not possible. Okay. So for example, like taking a changing your normal lock into. So nowadays we are all are using normal key for the homes, right? Normal manual keys for the homes. So just assume that when we are putting in a fingerprints or else iris or else pin code like that, is it possible to do with the normal key to open that? So it is not possible to do with the normal key, right? So nowadays we are using normal locks, right? So instead of that, we are using in a smart key, like in a pin key or else iris key or else what is that thumb key. Okay, so with the normal key, we will open that smart keys. That is not possible. In the same way, so now we have normal encryption methods like RSA, ECCs, right? So when the post quantum cryptographies are introduced, so is very like powerful for the encryptions. Okay, then so like changing as I said, like changing your normal lock into a smart lock that needs a complete different tools to open that. In the same way, changing from ECC to or RSS to quantum cryptography encryptions, it is very change thing to open that encryption. Clear? Right. So, so what are the new safe algorithms we have? For that, those companies and those countries already developed few algorithms. The algorithms are lattice-based algorithms, hash-based algorithms, code-based algorithms, and isogeny-based algorithms. In that, already implemented algorithms are lattice-based algorithm. So we have already used from US as well. So that is NIST. They have developed this lattice-based algorithm. So that name is Crystal Cyber. Crystal Kyber, I think so. Yes, Crystal Kyber. The same way, we have a hash-based algorithm that is spin chess plus, I think so. Yes, spin chess plus. So it is in test mode right now. It will be available within 2 to 3 months, I think so. The test is already done. The same way, we have code-based algorithm that is MC Elix license, I think so. MC Elix license. Okay. So these are the algorithm now we have in the world. These are the very powerful algorithm. Okay. So with using these algorithms, codes are very safe. I hope the clear is everything clear, right? So in another way, some simple solutions. In meantime, if we follow that, the algorithm is safe. The data will be safe. So what the simple steps are? So generally nowadays the companies the organizations are using this, even though the government of India also using this. That is, use bigger keys. Like so, we have a example. Take an example. AES 256. Instead of that, so instead of AES 128, we will use AES 256. So this is the best way to protect our data from the quantum computers. Okay. The same way, adapt PQS standards. It means that the governments are planning for that in India as well. As I said, UK or US are already followed these things. So already being tested by government worldwide. Okay. So they are searching how we will adapt those things. Okay. Simple way, in a simple way. So current locks are, as I said, current locks are what RSA and ECC, right? Can be opened with a universal master keys, like Shor algorithms. But when coming to PQs, like we are changing into the PQs to lock this with biometric smart locks. Clear? Right. So next, I hope clear, right? So as I said, NICT's post-quantum cryptography standardizations. So these are the UK-based standardizations. So in the 2016 and 17, so they were started with some amount, some count. So in the 2019, they were released 26 algorithms. In the 2020 and 21, in the 26, so 7 main candidates or 8 algorithms are getting ready. Okay. In the 2022 or 23, the full crystal, as I said, in a crystal stratal kyber, right? The encryption algorithm was released. As I said, same in the Spinches Plus, Falcon, Dilithium is already released in 2023. So additional standards are expected by the 2024 plus. Like, so still the testings are running. Okay, done. Okay then. So next, hybrid cryptographic approaches. So how did we implemented that? So why hybrid cryptography? So basically, the thing is that so the development is still going on. So in the world, in your life, so just assume, just think yourself. In 2020, how you will be? Okay. In present, how you are? So this is a different. The same way, so we have to update it in the quantum as well. That's why the hybrid cryptography is important here. So it will be maintain the backward compatibilities with existing systems and reduce the risk during the transaction periods. And it allows incremental implementations and testings, and it provides security against the both classical and quantum attacks. The same way, it will protect the against potential weakness, whichever having the new algorithms. So that's why the hybrid cryptographic approaches are very, very important. So implementation approaches are, we have some types for that. So one is classical encryption, another one is post-quantum encryption. Next, as I said, key agreement, integrity and authorizations, and last but not least is combined secure messages. So that's the reason hybrid cryptography approaches are very, very important in the to the world. Okay, next. So is there any difference between the performance in the normal computer and the quantum computer? Yes, we have the performance difference in the both. So I already said with the real-time examples to you guys. The same way, it is in a symbol, it is in a numeric symbols only. So in the key sizes, so it will be approximately 10 percent to 100% difference in the key size increases. In the computational overheads, it is between 2 to 5%. So in the signature sizes, it will be comes in at 3 to 8%. Okay, the same, right? Clear? Right. Next. So the topic name is crypto agility. It is the key to quantum readiness. So what's a crypto agility? So crypto agility is the capability to quickly switch between different cryptographic primitives without significant system changes. So it means that uh, so it is the main thing to we do within the cryptographic primitives. Like we will take one algorithm from one source and another algorithm from one source. So we will merge this one into cryptography. Okay. So the key components of included in cryptography is, so one is abstracted cryptographic interfaces and parameterized algorithm sections. As I said, the combinations and runtime configuration options. So in before we are in the ECC and RSS, we don't have runtime configuration options, but in the cryptographies we have that. The same way, a seamless algorithm rotations mechanisms, like it doesn't make any changes in the algorithm. So if you want to change immediately, it will be appears. Okay. So why it is critical? It means that uh, that is the essential benefit for the measure of quantums. Okay. So why it is critical? It means it enables rapid response to the cryptographic vulnerabilities, and it allows phased implementation of new standards and reduce cost of cryptographic transitions, and prevents being a locked into vulnerable algorithms. As well, facilities testing of quantum algorithms are involved here. So that's why it is critical, right? Right, fine. Everything is fine, right? Next. So how we will develop or how we will implement a roadmap for this. For this, we have a roadmap. Okay. So the roadmap involve 5 steps. One is inventory, another one is crypto agility, and third one is hybrid transitions, and fourth one is critical first, and fifth one is global cooperations. So inventory means that list of all RSS and ECC based systems. Okay, so we have to make a list from before we have a algorithms, right? So from that algorithm, we have to create a system. Okay, we have to maintain a list for that. Next, crypto agility. Just now I complete that, but I conclude with a shortened way. Make a software to flexible changes to the algorithms. Okay, with the combination of two algorithms or whatever. So make it as a flexible algorithm. Then next, hybrid transitions. It means that it means that combination of run old plus new crypto together until a stable thing. Until a stable thing. It is nothing but hybrid transitions. So the fourth step is critical first. It means that prioritize the bankings, others, defense, healthcare, and government websites. So we have to uh, find the importance of critical things. So in our world, in our daily life, so the UPI is important. Okay, it means that banking. Next, our personal security is important. It means that other. The same way, our nation is first, right? So for that, we are using defense. Okay, so that is our critical first priority. In the same way, the health. So the health is our major priority from nowadays. I hope you understand. Okay, done. Next, the final step is global cooperation. It means that, so working with NIST or ISOs or BIS to adapt. So few things, like we have, these are agencies or organizations. So NIST is from UK, sorry, US, ISOT from UK, BIS from our India. Okay. So collaborate with all the organizations to build or to create an PQC standards. Okay. So that is the global cooperations. I hope you clear. Done. So example, for this, how we will work on this. Take an example. So US National Security Memorandum was launched in 2022. So they gave agencies around the list, I think 20 plus agencies. So within 120 days, they give the permissions. In the same way, the India is work as same. The creation of these power algorithms, these Scoops algorithms are powerful algorithms will introduce in India as well. Okay, right. Next, common implementation challenge in just when we are creating these things like quantum computers. or else algorithms. So we are facing two types of challenges here. One is technical challenges, another one is organization challenges. So coming to technical challenges, so first one is legacy system, and second one is performance limitations, and third one is complex dependencies. So coming to organization challenges, the knowledge gaps, we have a number of the sufficient persons don't have the knowledge gaps, so they don't have sufficient knowledge. In the same way, resource allocations. So in the government sector, as we know, we don't have that much allocations. Coming to resource companies, they don't have permissions for that right now. Okay, next timeline. It's the typical thing in the world. So why? Because they already developed those algorithms in the world. So compared to the world, the time we don't have that much timeline for the India. Okay. So coming to the technical challenges, legacy system constraints means that so many systems lack crypto abilities or how or hard code algorithms are depends on uh, few basic algorithms only, like basic things only, right? So coming to performance limitations, we have only some PQC overheads. It means that we have only some systems are will work with a few much steps only. Okay, for that we have some limitations only. Then, so in the same way, complexity dependencies like third-party integrations in the India, we don't have agencies for the implementations. Like even though government is not ready to collaborate with agencies. Okay, this is a major problem in India. But in the US or UK, they are ready to collaborate with the new agencies or new companies to create in this type of new quantums. Okay, right. So what is the regularity and the compliance landscapes we have right now? So as I said, US National Security Memorandum is launched in 2022. They are well developed right now. They are already well developed. Sorry, someone is making disturb, right?
Yes, sir. I muted her, sir. Please continue.
No worries, no worries. So right, the US National Security Memorandum 2022, it was already well established, and it was already launched few algorithms for that this cryptography, and for this quantum also they have sufficient systems compared to our India. Okay, so quantum computing cyber security Prereadiness Act is already launched in the NSST only. It is all from the US only. Then next, so EQ quantum strategy. It means that provide funding directions of quantum readiness across EU digital infrastructures and critical systems. It means that the government will take care of the funding as well. So if anyone interested to do something regarding the quantums or cryptographies or algorithms, so they will provide the fundings. So we are already know. So some students are having good knowledge, okay, but they don't have economical thing. So for that kind of persons, the kind of things, they will provide the fundings. Okay. Next, last but not least, the industrial standard bodies. So we have ISO, we have IEEE, and we have ETSI are ready to developing standards of quantum safes right now. So this is from India only. It is for safe, safe cryptography implementation and validation purpose. Could you please give me a minute? Okay. Hello. Hello.
Yes, sir. Sir, unmute yourself, sir. You are muted.
Yes. Sorry, sir. Call. Okay. Yeah. Done. Is it clear, right? Sir, are you there, Mohan
It
sir?
is fine, sir. Please continue.
Yeah.
Please
Yeah.
continue. It
Okay.
is
Done.
okay.
Yeah. Done. Next. What are the takeaways and next steps? So the first one, I conclude that, okay. So for the professionals, I conclude this thing to be, this is a very important thing, okay. So quantum computing is a boon or a threat. If we don't move to quantum safe security, our digital lives like banking, other UPI defense, or whatever so we are using, right? It will be at risk. Okay. So India must prepare a adopting post quantum cryptography quickly. So I have to conclude this as well. So you people are aware of quantum computing. Be ready to develop algorithms, quantum computings, everything related to quantum computing. If you have interest, please let me know. Why? Because we are looking to some kind of persons. So if anyone interested, once the session is done, please get back to us. Okay. So what is the key takeaways and next steps? It means that the quantum computers are coming faster than expected. So we don't expect this much speed they have. So this much development have done in quantum computers. Okay, so RAC and ECC cryptographies will completely fail against source algorithms. It is tested by the US government. Okay, and in ACCs, the ACS 256 and PQs are the only safe paths right now. We don't have any alternative things. With using RSCs and with using ECCs, we don't have that much security. Okay, with using real-time computings like in the banking as well, we don't have security. Then, so India must adapt PQ quickly for UPI and Aadhaar and defense things. I hope you understand, right? So final conclusion from my end. So quantum computing is like an electricity. Simple like is an electricity. In the right hands, it will be done. It lights up the cities. The right hands, it will be done. It light up the cities. In the wrong hands, it will be done. It can be allocate all the entire nations. Yeah, it means that it will collapse our India. I hope clear, right? So this is my side. If you have any queries, let me know.
Yes, participant if anybody want any questions, unmute yourself and ask the question.
If you don't have any queries, we have another session within 30 minutes. Okay. I hope everything is clear, right? So you all are aware of quantum computing, right?
Yes, sir, it is very clear and informative.
Okay then. So we will connect within 30 minutes, sir. Again, we have session, right?
ఏది
So it
బయట
is the
మనకు
advantage of.
నివసించడానికి బ్రతకడానికి మంచి
Sorry.
Yes, sir, yes, sir, yes, sir, yes, sir, of course. Okay.
Okay then. So thank you, sir. Thank you for your time. So thank you guys. So thanks for your time. Okay.
Again, we will connect 7:30, sir, right?
Yes. Yes. Okay then.
All
Thank you,
the
sir.
yes, sir, all the participants can take a break of half an hour. We will meet 7:30. Don't leave the call. Please be in the session, but you can take the break. Meanwhile, we will post the feedbacks link in the chat box.
Okay, sir. I will be joined around 7:30. Okay. Thank you.
Thank you very much, sir.
Yeah.
Dear participants, Day 3 quiz is available in chat box. Please click the link and submit. Thank you very much. Dear participants, repeating one more time, Day 3 quiz is available in chat box. Please click the link and submit the quiz. Thank you very much.
your nose. You have two holes in your nose. In the cavity nostrils, the arteries, nostrils, the anterior, nostrils, right? All have to go in your nose, nostrils, from your nostrils. Yes, very good.
Sir, welcome back. We will start 7:30 sharp.
Yeah, sure, sir. I'm audible to you?
Yes, sir, you are very clear.
Okay, then.
Sir, shall we start, sir? Sir, please start, sir. It's 7:30.
Yeah, sir. Done. So my screen is visible to all, right?
Yes, sir, your screen is visible. Audio is
Yes.
also clear. Please
Yeah,
continue.
yes. Right. So now going to discuss regarding the cybersecurity strategies for the quantum safe future. Right. So in this session, we will discuss regarding the risk by the sectors, how timeline will be of the quantum evaluation, and what the tools we are using, and what is the real-time scenarios, and what is the post-quantum cryptographies. So why PQC? Like that, we are discuss deeply regarding the cybersecurity strategies for the quantum safe future. Okay, right? So I think you are clear with the before session, right? So in this session, we are discuss about quantum threat landscapes, post-quantum cryptography's fundamentals, strategy transition approaches, and implementation roadmaps, and industry case studies and next steps. Okay, done. So the quantum threat. So already we discussed regarding the threat, how we will be attacked. Okay, regarding all the things. So next, the quantum computing timeline. So how it will be grows. So calculate from the 2023 to 25. So the noisy intermediate scale quantums NISQ era was bit from SU 50, sorry, from 50 to 100 qubits, the system with limited error corrections. So from 2025 to 30, it will be improved into 1000 qubits with the potential to break the risk. So RSA 2048, and it will improve error corrections and scalings. So in the 2030 place, so the it will be acute the fault tolerance quantum computers and practical sure algorithms implementation on all the cases and threatens all public key cryptographies. So this is the timeline of quantum computing after 10 years. Okay, right then. So what are the risk factors we have? As I already said, we have national security risk like military, okay, army, DRDO, like intelligence operations. So these risks we have. Next, financial infrastructure risk in the banking, the payment gateways, in blockchains, right? In the currency as well. In the healthcare, already we discussed those things. Like patient records, medical devices, pharmaceuticals R&D's data as well in the risk. The same here the add-on is cloud infrastructures. Nowadays, we are all are using Google Cloud or else Amazon Cloud for the storage. So anyone, even though they don't know the technical things, technical terminologies, they will save their photos into Google Drive, right? So even though we are also using Google Photos, so it will be automatically store your photos. So at the time of storing, there is no glitch. So, but the quantum computers that existed, your data will be stolen. So this is the best example for the cloud infrastructure. So how it will be, we will see. Okay. Then next. So, so in the government, so cloud in the sense, not only your personalized things. In the government also, we have workloads for AWS, Azure. So even though if you have knowledge in NIC cloud, so even though there is a glitch as well. So coming to healthcare, already I said, right? Clear? Next. So for this, we have some things like we have tools for that. So in the IBM, we have a tool for the shores. So it is already developed. The tool name is QuizKit. So it is assimilated to shores algorithm on small RSA. Okay. So same like that, we have a tool that is Vershark TLS Analyzer. So it shows the dependencies on RSA and ECC in real-time profits. Clear? Next. So as I said, the harvest now decrypt later, right? So this is the key takeaway. So harvest now decrypt later is that stolen the data today is a liability to tomorrow. Okay, so it means that what, so stolen data today and it is in a liability of our tomorrow futures. Okay, in example, as I said, Aadhaar linked health records. So it is be going on right now. So before we don't have this, so but it was implemented in 2030. I hope so. So Aadhaar linked health records encrypted today maybe. Take an example. Okay, it will be stolen with at the time of the quantum data is present in the world. Okay, right. So this is the just vulnerable cryptography standards. So in the RSA, we have RSA and DSA, it is 100%. The ECC, we have it is a 100% only. But in the H key exchange, it is only 65%. Okay, then next. So what is post quantum cryptography? Already we said. Then, but why the post quantum cryptography we need it? So we have to discuss those things here. Okay. So why PQC? Is there any idea in the session, guys? So if you don't have idea, no problem. So I will continue. Okay. So why PQC is means that it is in a classical cryptography. It's in a classical cryptography. So it will change the RSS, ECCs, the HS into broken quantum computings. It will change the systems, all the systems. So that's why we need PQCs, post quantum cryptographies. Already I said, I will discuss, right? Next. So NICT PQ standardization progress. So why we need standardizations, first of all? So as simple as that, we don't have any standardization. Standardization is nothing but an worthy. Okay. So if you take, already we discussed regarding the clock, right? So if you want to take in a lock, if the lock is very loosey or it is not with the well, is it good? No. If the lock is very standard or if the lock is very strong, only it will protect your house. Then only it will protect your things, right? In the same way, in the same way, in the quantum as well, we need some standardizations. Okay. Further, the National Institute of Standard Technologies (NISTs) has been evaluating post-quantum cryptography algorithms since 2016 to identify the quantum resistance replacements of current standards. So whatever we have before, okay. So for the resolution of the quantum, so they will start at NIST. Okay. So already we discussed regarding the things in the 2022. Okay, the 2022 they will launch crystals kyber key and encapsulations. Okay, so in the same way, dilithium we are launched in the 2022 in Falcon as well. Okay, right. So draft standard of timeline. So initially in the 2014 they are published those things. The final standards are expected in 2025 to 26. Federal systems are migration by 2030. It is not done that much earlier. Okay, right. So coming to round 4 candidates, current we are testing the things. So one is by code. It is a KEM thing. Okay. So next one is classical MySQL. Already we will discuss this in a code based KEM. Then next HQC, and it is already KEM thing, and Psych. This is already a broken thing. So okay, done. Right. So PQC algorithm comparisons. So what's the difference between, we are already discussed lattice based, code based, hash based, multivariate, right? So in this lattice based is nothing but coming to, we have few variations here. So the lattice based is nothing but finding status vectors in the lattices. Okay, the key size is medium from the lattice based. The performance is excellent. The maturity is high. The same way comparatively code based as coming to, it is decoding random linear codes. The key size is very large. The performance is good. The maturity is high. So coming to hash based, it is a collision of resistance of hash functions. The key size is very medium here, and the performance is slow signatures. The maturity is very high. So like multivariate is coming to security bases, solving the systems of multivariate evacuations. So the key size is very large, the performance is fast verification, and maturity is medium. Done? Right. So in the finalist of 2022, we said, right? So what we have, crystal, kyber, crystal, dilithium, and faculin and spinches, right? So these are proved things with using these algorithm comparisons. So these are launched based on these comparisons only. Okay. So in the basis of previous things only, they build these algorithms. Okay. Next, right? So strategic transition of approaches. What we have, so we have a hybrid cryptography. Already we discussed these things. So this is the fastest, safest, and fastest path towards the world. So hybrid cryptography combines. So before we're going to start, so hybrid cryptography is nothing but combination of classic and post quantum algorithms. So it is ensures that the security levels in never fails approach, right? So how it will be safest thing? It means that based on this implementation process, based on the security guaranteed process, based on this standardization, it was very safest path. Clear? So that's why hybrid cryptography is very safe thing. Done? Okay. So next, crypto agility and future proofing your security. Okay. The crypto agility is the ability to rapidly switch cryptographic algorithm without significant system charges. changes. So essential for responding to quantum advances and algorithm vulnerabilities. So we have four things here. One is abstraction layers, another one is pluggable components, and third one is algorithm identifiers, and the fourth one is re-encryption pathways. Okay, so done. So in Indian context, so if you hear any missions like that, so the Indian mission is, so before going to discuss this cryptography, they have an Indian mission that is MITY, so National Mission of Quantum Technologies. It's around started with the 800 crores. So ISRO started in a communication satellite that with quantum, and the Noob Labs. So in Bangalore, this is the first quantum security startup. Okay, these ISROs, QNLOOPs, and METs, why? These are all are followed these crypto abilities. So why? Because this is the future proofing your security. So that's why they are followed this all the components. Okay, next. So what are the tools they are used for that? They are used some tools for these things that are open quantum. So that is LibOQs or OpenSSL or OQS. Yes. So next thing is, okay. The next thing is that zero trust and layered defense models. Zero trust and layered defense models. So here zero trust have some principles. So in that the principle, the very explicitly things. It means that never trust, always authenticate. It means that don't trust anyone. So you should be authenticate. Then only it will be work. Okay. So even though nowadays we are following in our things, in that we are following this thing in your mobile phones. Okay, your mobile phone sensor is there, na? There is never trust you. So if you are authenticate personally, it will allow you. In the same way, they will implemented zero trust in quantum layers. Okay, so this is the apply latest least privilege access. Okay, then next, assume breach has already occurred. So it gives a what? It gives an impossible creative to the world. Okay, so zero trust models are reduce the impact of cryptography failures by limiting the scope of duration of access, even with valid credentials. Okay, so layered cryptography defense is that says that multiple independent cryptographic boundaries, and it says that different algorithm families at each layers, and separate keys of security domains, and quantum resistance key derivation functions. Okay, so implementation for the roadmap. So we have some implementation roadmaps here. So that is step by step migration. Okay, so here the thing that involved in this one is cryptographic inventory. So for that we have tools, CISA PQ inventory tools, or Venafi, or key factors. So identify RSS or ECCR independence across the apps. So at that time, APIs and HSMS are involved in this. Okay. So next, the next step is implementation roadmap is risk assessment. Risk assessment. So we have to assess the risk. So we have to classify the data, even though it is in a government activity or even though it is in a private agency. So we have to migrate the all the risk assessments. Clear? So we will take the 25 years of a risk list from that risk assessment. We will collect all that risk things over there. So next step is testing and benchmarks. So we have to test in the lab testings or in the test VPNs. We should perform the testing in the lab. So Kyber and Deletium performances are done in the lab testing only. Next, we should test with VPNs and TLSs and identify systems. So where we already using for the test purpose, we should test these algorithms. Test these algorithms. Then the fourth step is phased rollout. So phased rollout is nothing but So we should take in a pilot project. So with using VPN gateways or cloud services, we should test the released quantum strategies is over there. Yeah, okay. Then the full rollout with the monitoring and terminality. So if it is success, we will go into continuous validation until unless or we will do the tests on that. So like re-encryptions or crypto updates or crypto aggregates, we do these things in continuous validations. Okay, right? So these are the things. So here the thing is a risk assessment framework. So we use a risk assessment framework for the finding the glitches and finding the problems we are facing. Okay, authentication systems or whatever we have. So we have to create a framework for that. So in that framework, we should show the possibilities and the risk analysis and risk records as well. Okay, done. So this is a general thing, right? The final is industry case study. So what are the industry case studies we have right now? So all of you aware of JP Morgan, right? JP Morgan, AWS, Google, NSA and the CNSA 2.0. So JP Morgan already started a industry thing. The tool or the algorithm name is PQC TLS with the Kyber. Okay. In the same way, AWS already used that one. PQC TLS in SE3 and CloudFront. In the same way, Google also PQC hybrid in Chrome. PQC hybrid in Chrome. So finally, the government thing, that is US migration thing, NSA and the CNSA 2.0. It is for the roadmap of US Gov immigrations or migration persons. Okay, these are the industry examples right now in the world. So as I said, JP Morgan is worked on financial sector. Okay, AWS worked on cloud providers. So Google has the same in the cloud providers. So in the government of defense, NSA. So CNSA, it is called as CNSA. NSA CNSA 2.0 for the migrations or immigration persons. Okay, so these are the real world implementations example. Still they are using these things. Okay, so the JP Morgan Chase has tested post quantum TLS connections using crystal skybus. Already I said that for the key encapsulation. Already we know encapsulation things. Okay, so they also begin mapping their cryptographic state and identifying high value applications for yearly migrations. The same way, the cloud providers is AWS and Google. AWS has released post-quantum TLS for S3 and CloudFront services. In the same way, Google has implemented hybrid key exchange in the Chrome. It is rolling out PQs for the internal services only. So still they are using for the internal services only. They are not ready to expose these things to the public. So in the same way, NSA has published this commercial national security algorithm, SHOOT 2.0, for protecting classified information for the migrant people, for the immigrant people. So the federal agency is there in US only. So this is involved in this migration, okay, and immigration people purpose, right? So next, so the final thing is that, okay, in the Indian people, so these are all from US and UK, from the other countries only. So what about our Indian people, Indian examples, coming industry examples? Okay, so we have the only company is BSNL with CDOT. BSNL with CDOT. It means that it is still trials only with the QDT between the Delhi and Mumbai. So they are doing the trials in the QDT. Okay. So the another company we have, that is SEBAR RBI. You already know that, I think so. They are forming the PQs. They are not in implementation stage. Only the BSNL is giving the trials on that. So, but the SEBAR RBI is forming PQC work from groups for the financial resolution. Then the next. So in the Indian context, only the thing is MITE. Already I said MITE, National Mission of Quantum Tech, or ISRO already is doing that, and the startup like QNOB, they already developed these quantums. Okay, right? Security things. Finally, that what are the case studies we have here? So So some case studies here. So I observed the case studies from my end. So earlier adapter shows passed with place hybrid adaptation works best. Okay. So in the organization level, so we have to follow few things. One is start crypto inventory today, design for the crypto agility, and engage with standard and GOAT audience guidelines. Next, train teams in PQ migrations. So these are the case studies I observed from my personal way. So we have to follow in the organization these things first. So start crypto inventory today, design for the crypto agility, and engage with the standards and GOAT guidance. Next, train teams in your PQ migrations. So coming to financial sector, what I observed is the JB Morgan or Indian bank exploring the quantum safe digital payments right now. That's why they are designing these JP Morgan Chase. Okay. The cloud sector, AWS and Google already rolling for with the PQC TLS. Done. So in the defense or GOUT in sector we have NSA and CNS. And even though in India we have ISRO Q common project, right? So coming to key lessons, what I observed is, so first of all we have to ready to build hybrid approaches, like is the safest term for this. Okay, so we have to do hybrid approaches first. The next, we have to design crypto utilities. Must should we have this thing. So the final thing is that prioritize data with long shelf life. Like we are making in a priority with legal things like other things and different things and health case. Okay. So finally, what tools we have in this? Yes, we have some tools in this. That is AWS KMS PQ Pilot. So this is the tool for this safest designing of the algorithms. Okay. In the same way, we have a Microsoft PQ Crypto VPN. The same way, we have Open Quantum Safe GitHub repository. It is ready to use library. Okay, right. Next. So I will share another screen. Please wait a minute, guys. Okay. Is it visible, right? Guys, are you there? Is it visible?
No, sir. Screen is not visible.
Okay, okay, wait a minute, sir. Now is it visible? I hope now it is visible, right?
No, sir.
Please check. I think is it visible? Right? Is it visible?
No, sir.
No, sir.
Yeah, wait a minute. I will check with my network connection. Yeah, now is it right? Yeah.
Yes, sir.
So I conclude regarding the before session is that start now few things. Do a crypto inventory, try hybrid PQC pilots, and align with NICTs, CISs, and MITES, and RBI and SEBI guidelines. So you people are interested, okay, do these things first. Okay. Next, the next topic is post quantum cryptography global standardization efforts. So what are the post quantum cryptography global standardization efforts? It is a comprehensive analysis of NIST standardizations. Sorry. So that is the process of this is the process and global innovative to prepare our digital infrastructures for the quantum threat. Okay. So the quantum threat, why standardization matters. So why already we discussed, right? So that in the standardization. Okay. So the quantum computers will be break widely used public key cryptographies. So it is a potential compromising in digital signatures, key exchange protocols, public key encryptions. So standardization creates a confidence in the replacement of algorithm by ensuring they undergo the extensive crypto analysis and validations. It means that they will build the replacements of algorithms with the standard ones. Okay, so next, NICT post quantum cryptography project. It was started in 2016 for the call proposals. Okay, they will take 69 candidate algorithms submitted by the evaluations. Okay, in that 69, in the 2019, it was conducted 2 rounds. Okay, the 26 candidates are advanced after initial security and perform the analysis over there. So they are 26 candidates are shortlisted here. In the 2016, it was started. The candidates are submitted algorithms to the NISTs. In the 2019, they were conducted 2 rounds. In the 2 rounds, the 26 candidates are shortlisted. The 2020, the round 3, the 2027 finalized list is over there with the 8 alternatives. Okay, in the 2022, the first standard Kyber and already I said Dilithium and the Falcon and the Spinches 5, Spinches Plus is selected. So in the 2024, okay, so additional of chems or signature are expected. So I think it will be launched within few months. Okay, so this is the NICT PP project global things. So this was happened in NICT from the 2016 to 2025. Okay, the why the standardization matters again. The standardization is nothing but trust plus interoperability plus migration guidance. So these things is presence in standardization only. So quantum computers will be break RSA, ECCs, DHS. So compromising these digital signatures, key exchanges, encryptions, we do have standardization. Okay, we must should follow standardization matters. So without global stands, like we have few global stands chose. So each country and company using different algorithms for interoperability for the security. So that's why the standardization is matters. In an Indian level example, we have NPCI for the UPI transactions. So already, if you're aware of UPI transactions, so there is a small icon for that. So it is provided by the banking sectors only. NPCI. Okay, if it is chosen a non-standard PQC algorithm, while global banks use NIST's Kybers. So international payments may be break. Okay, so this is the risk we have in India right now. Then, okay then. So NIST evaluation criteria, how it will be worked. So it means that they follow some algorithms. First of all, already we discussed regarding that algorithms, Kybers, Dilithiums, Falcons, Spinches S plus. Okay, so for that we have a few tools. Okay, so the tools are Open Quantum Safe, QUS. Already we will discuss. This is for the test TLS with the Kyber and Dilithiums. Next, IBM Quizquit. It is run lattices based algorithm demos. The next ABM KMS PQ pilot. So it is for the developer can already test the quantum safe key exchange with using these things. Okay, so coming to NICT is evaluation criteria. They follow these things. One is security, next one is performance, and third one is implementation. In the security, they check resistance to no quantum and the classic attacks, how it will be worked. So the second point is they check the security margins and the mathematical foundations, how it will be appear. The final thing is they check the side channel resistance. So in the performance, coming to performance, they are checked with the key sizes and signature lengths. So how it will be goes and how will it be performance things over there. So finally, they will check with the computational efficiencies. So if you save in a file, how much time it will be take? If you do an implementation complexity, how time it will be take for the running? Okay, so these things are the check. Okay, so these evaluations are happen in NICT evaluation criteria. So the final thing is implementation. So they are very capability to do, or they are very capability to perform hardware and software things, and they should have the resistance to implementation attacks, and they must should be perform in a simplicity of an implementation things. So NIST is a sort of a diverse portfolio of algorithm with different security fundamental and foundation things to mitigate future cryptography things. Okay, so next, international standardized PQ algorithms, that is uh, not only Kyber, we have some global bodies over there. The one global body is ISO. So we already knows ISOs, IECs, and JTC ones, ETSIs, IETFs, and ITUC ones. So before going to that, the standardized PQ algorithm is Kyber. So we already discussed crystal Kyber a number of times, right? So it is Kyber in the sense key encapsulation mechanism. It's performed with the key encapsulation mechanism only based on the module learning. So with errors, the MLWB problem, some glitch error. So selected for it is balance of security performance and key size. So this performs a profile across diverse platforms. Okay, it performs and all the profile across the diverse. So without depends on the platform, it will perform things. Then the flexible security levels are Kyber is 512, 768, and 102 versions. So this is a bit size. Okay. Next, so it is in a simple implementation thing that we have in Crystal Kyber. We don't have that much complexity over here. Then next, standardized PQ algorithm digital signatures. So we already discussed these things. Crystal dilithium in the same way. So this is the primary general purpose of signature scheme. So it is a balanced security efficiency thing. So it is performed signing process, simple for the signing process. The same way Falcon. The Falcon is in a based NTRU lattices. It is a smaller signature than dilithium. It is comparatively smaller than dilithium. So it will perform more complex implementations. So it is used for bandwidth levels like bandwidth consideration. So we have no applications, right? So for that application, we use this Falcon. We have Falcon TVs, right? The same way they are using for the bandwidth purposes only. So Spinches plus, so it is an hash-based signature thing. So with using Spinches, we do security assumptions like if you want to perform any security thing more protective. So the assumptions we are creating from the Spinches plus. So here the larger signatures and slower signatures are both are allowed here. So then what we do exactly do is we do back options with the different security foundations. Like we do perform different steps here. Okay, done. Next, performance comparison is there. We already discussed this in the first slide as well. Okay, so these are the common things. Then next. So what are the international standardizations efforts? So how the international bodies are work on this? So as I said, ISO, IEJCTC1 and SC27. These are working on a quantum resistance algorithm standards. In the same way, the major thing is working here is that I2U T is a telecommunication security standards. The same way for our sense, it's an internet protocol that is IETF that is integrating PQ into internet protocols. So for the cryptograph, we have an ETSI, Quantum Safe Cryptography Working Group. So this is the major international standard for our SEEK, for the cryptography SEEK. Okay. The next. So in the regional bodies, how many international standard teams we have is that in EU we have a ENSIA or NIS2 directives. In the China we have SM2P or Rainbow. In the Japan we have Cryptography or Psych Research. So in the Canada, aligned with the NIST, but with the local implementation rules are they are already upright. So these are the efforts from the EU and China and Japan and Canada. So coming to our India, so India is still they are not compatible with these standards. So they don't have such a rules for this interoperability things. Okay. So next, this is already discussed. Okay, done. So standard challenges already we discussed. So in depthly we want to know these things. Okay. So first one is rapid cryptanalysis. So as said, Psych from the Japan. So Psych was broken in 2022. So even while under SIT review, so it was broken by the SNIT review in 2022. So this is a challenge the Japan people was faced in 2022. Next, the implementation complexity or implementation overhead. So PQ keys are a signature larger. So these are happens in IoTs and the SIM cards or UPI QR devices may struggle things. So these are the problems they are facing in IoTs, SIM cards, UPIs, and QR devices, and increasing the risk implementation flaws. Okay. So the third one is protocol compatibility. So it is happens in TLSs, IP6, and VPNs. And if they need any extensions, so they will face these protocol compatibilities. So protocol limits is legacies are compatible issues creating an adapter of standardization challenges. So the final one is regional fragmentation. So it is nothing but multiple competing standards, and it means that interoperability issues like different algorithm, different framing forms and framing things for augmentations are caused this regional approaches, regional fragmentations. Then, so for that we have some tools. So the tools and the actions are so, in enterprises crypto inventory. We have a tool that is Benefi or key factor. So for the free and open source, so this is a simple thing that is CISA PQ inventory tool. So for the guidance, we have a practical playbook that is Gen C COE migration guides. So, okay. So in the real time, as I said, in the same way BSNL in India level, we are using BSNL plus the combination of BSNL and CODT and QNU labs. The quantum key distribution tested between Delhi and Mumbai. Okay. So in the IoT pilots in EU, so they are tested PQCs on smart meters are showing 10 to 15 overhead, but workables are not. Okay. Next. So academics of contributions to POE standards. These are the fundamental the four types we have here. So that is fundamental research, and next one is cryptanalysis. Already we discussed optimization, and the I missed here knowledge transfer. So in the next generations, we have to train on cryptography. The same way we have to train them into security engineers. Then only we have to stop this, or we have to stop this risk and maintain the PQC standards. Okay, so we do follow the fundamental researches, and we do follow previous research what we have, and we do have knowledge and crypto analysis as well. So how to find the weaknesses in the algorithms roughly, and we have to maintain any analysis reports. So finally, automation is nothing but improving the implementation efficiencies or reducing the computational overheads. So it means that we have to implement every time. So if we have any single algorithm, so we should work on it. So we should work on it, and we should create a report regarding the crypto analysis. And if there is any changes will be occurred, they needed. So we have to do optimization again. and finally, we are ready to share our knowledge to our future generations. Okay. So next, in the industry adoption considerations. So what the industry want to adapt. So how they ready to do these things, right? Next, in the government level, so some industries already adapted. Like in the government level, the US, EU, and India also. So India also uh, do some changes on this. They are already provide 800 crores to develop these things, and they provide some trainings and all the things with using a business scheme met y met y. Okay, so right. Next, in the academics, we don't have any process regarding this in until 2022. But after 2022, we have the progress in IIT Madras and the TIFR working quantums and IISCs. So they are already created some quantum lists for the safe protocols. Next, in the academics, IIT Delhi and DRDO with the combination, they are started researching on PQ algorithms. So they do starting this, I think, from 2022 onwards, I think so. Okay. Coming to industries, so we have discussed regarding the Google AWS Cloudflare, right? So they already started the pilot projects and they already test those things. So in the Indian startups, we have only the companies QNUBs. Already we discussed that the QNUB labs were quantum hardware plus PQCs, only PQCs. So they don't do any testing still now, but they do some things in quantum software, that is for BFSI. So the software name is Bosho NuQ PSI. Okay, Bosho NuQ PSI. They already done that one, so that is available for the BFSI, border security force. They are already use some things only. Okay, next. So this is the normal industrial adoptions. So the industrial adoptions, industry leaders are approaching PQ's adoptions with the strategic cautions. So balancing security needs with the practical implementation concerns. So in that, we should have must crypto agility building systems that can quickly adapt to the new algorithms and hybrid implementations, to combining classical and quantum resistance algorithms, so backward compatibility, so ensuring the system work with the both old or new protocols. So if we have any better thing in the old protocol, it should be work with that. Okay. So the final thing is risk-based prioritizations. So it means that addressing the long-term sensitive data first. Then, so current integration status. So as I said, in the 2023 we have Google Cloud Flare, AWS implementation, experimental things and PQC in TLS. So coming to 2023 to 2025, we have some plannings for that protocol integrations. That is TLS 1.3 and SSH and IPC6 and X.509 certification standards. So it means that they are ready to launch some support things. Okay, the 2005 we have a planning in 2025 to 27. So this enterprises adoptions. So widespread implementation in financial services and healthcare and critical infrastructures. Coming to 2018 to 2013, so it will develop a lot. So I hope it will become into the world with including IoTs and embedded systems. Right. So building global quantum safe infrastructure. Yes, it is a safe infrastructure. So creating a truly quantum safe global infrastructure is required coordinate efforts across multiple domains. Done. So in that, the first one is hardware security models with PQC algorithm supports, upgrade cryptographic libraries, APIs, and certificate authorities and supporting new signature schemes. Okay, and key management system are handling large key materials and network infrastructure accommodating increased bandwidth. So done. So what are the future? So what is the future of this outlook or roadmap? So I simply conclude that the phased timeline is start just now in the 2022. So we are in initial stage with the initial standards. So coming to 2024 to 26, the protocol integration is done, I hope. So coming to 2026 to 28, the certification and refinements is done. So coming to 2028 to 30, the legacy deprecations, like the implementation of all the things is done. So coming to 2030, the quantum safe defaults are being in the world. Okay, so don't wait for 2020. Crypto migration needs years, not months. So my closing statement is, so next step for security leaders. So next future is security leaders only. So they do the changes, they do the all the things with the full of knowledge. Okay, PQ is not in a future problem. It is today's migration project. It is not as a future problem. It is a today migration project. India must align with NIST and ISO to secure UPIs in Aadhaar and DigiLocker and CoWINS. So real actions today we have to do is crypto inventory to like a Verify or CAC. So like other states we did, right? The same way we have to do. Next, hybrid crypto pilots, like we have TLS with Kyber and Dilithium, right? In the same way we have to do. Next, crypto agility frameworks like APIs, model cryptos, like that. So finally, the training engineers in PQ migrations. So we need more training engineers for the future, right? So what are the resources we have? If you said like that, we have a number of resources. So the first one is, please note it down. If you want any PDFs or any data regarding this, please note it down. The first one is NIST PQs. The domain names or library name is csrc dot csrc dot nist dot gov dot slash projects slash pqcs. So you will find all the information regarding these things. So coming to Open Quantum Safe, so we have an openquantumsafe.org, right? So these are the resources for the your future generations. So they already developed some things. Clear? I hope. Is it clear, guys?
Yes, sir. Yes.
Done. So done my side. Do you have any queries regarding this session? So please let me know. If you don't have, fine. Guys, are you there? I
Yes,
think
sir.
everyone.
Participants, if anybody want to ask the questions, unmute yourself and you can pose the question. Sir, I think nobody have the question. Please proceed.
Okay, done. So is it done from my side, Mohit sir? So this is regarding my sessions. Okay, this is my side view and all the things. I'm done with this.
Okay, sir. Thank you. Thank you very
Okay.
much.
Thank you, guys.
The session
So,
was very wonderful and very informative.
okay.
Definitely, it is useful for our career as well as for research future endeavors. Thank you very much for your insights, sir. Thank you very much.
Thank you all. Thank you for your time and all the things. Have a good day, good night.
All the participants are requested to stay here. We will share feedback link shortly in the chat box.
Done. Bye, guys.
Bye, sir. Bye. Session 2 attendance feedback link is there in the chat box. Please submit it. All the participants, please click the feedback form and submit. After submitting, you can leave. Thank you very much.